Hi, what you see here is a WaveTech 859 programmable pulse generator. And this generator was, I believe, was made back in the 80s. And from the calibration sticker, you can see that this one was actually used by Lockheed Martin. And last calibrated date was 10 years ago, 2005. So I know this one is not working. I will show you what it does, and I don't believe it's economically, like feasible to fix it. But nevertheless, I wanted to show you what is inside and what the construction is. But before that, let's just turn it on to see what the issue is. So, by the way, this this beast actually takes quite a bit of power, and I have a energy meter measuring the power goes in. It right now takes about 300 watts, so it's quite substantial. Anyway, so as you can see that when it powers up, the LED, actually the LED here, it just blinks, right? And the GPIB, all those lights are on, and it doesn't really respond to any of the button input. So I suspect there's something wrong with the microprocessor section. And so anyway, so that's the state of this pulse generator. And right now, without further delay, let's take it out. Let's take it apart and see what is inside. So these basically were just some screws up on the top to hold it back, to hold the top on rather, and it's quite easy to take it apart. So I just removed the screws, and I think it's missing 2 screws here, but the cover is actually quite heavy. Now, here we go. So now the top is off. And now we have the top cover removed, and you can see that it's quite crowded in here. And this is a very typical construction back in the 80s and early 90s, where you can see that these are the each individual card that is plugged into a backplane. And the first thing I notice is that there are a lot of axes. If you notice here on this tabs, which means somebody probably had already gone through this and marked each board as a bad, things like that. And also there's a note. We can take a look later. I'm not sure what that is, but this particular unit is actually a 2-channel unit. So you will see that some of the boards, like here, and this one, these are actually exactly the same as one another. Basically, it's one for each channel. So let's take a look at each individual card to see what we have here. So let's start from this one. Let's pull it up. Okay, so this thing it's a little tight here. Okay, here we go. So let's see. Well, this one, it says it's a 859 GPIB made interface. So this is a GPIB card, and basically, what is interesting is that you can see these are actually opto-isolated. So these are all the optocouplers. We have quite a few of these. We have 1, 2, 3, 4. So we have a dozen here, and a dozen here. And then we have a few, let's see, what are these? I can't really see, but anyway, so we have a few 4Ns and a few 6Ns, 6N136. So these are the optocouplers. And let's see what else I recognize here. We have, let's see, okay, let me turn it around. These, let me see, what is that? That is probably MCP 6803. That would be a 68 series processor, the microprocessor. And this one, the 684AAP, is a, let me see, I think this is a GPIB some sort of like an interface card, interface IC, and then we have a bunch of programmable logic and some UV erasable ROM and some other miscellaneous. So basically, this is how back then the GPIB card was built. And what is nice about this one is that this is a opto isolated, so which means whatever is hooked up to this card is isolated from this unit. So to prevent any kind of possible damage if if something goes wrong on your test circuit. So, and this is not all yet. So if you look at the back here, there's actually a riser board, which is neatly connected to the main board via these headers here. This again is a very usual construction back then. Basically, they don't have enough space on one board, and what they ended up doing is either they stack them up or they split into multiple boards. So it's quite creative. And let's see what is on here. And what is on here, we also again have some like opto coupler. And we have some 74 series logic and LM339, I believe is a quad op amp, and some TL084, that's another JFET input op amp. So this is actually quite a beast compared to what we have today. Today a GPIB card probably is a single chip and no more than that, but back then, it's all pretty much discrete and 74 logic glued together. And one interesting thing to show you is that you see this these shapes here, and I believe those are the ones that to assist the opto recognition when during assembly. So the automated the robotic arm would recognize these shapes and to locate where the board is and relative to these locations where the components are. So now let's take a look at the second card. So again, we can take it out easily. And this looks like it's a processor board. It's the main processor board, which unfortunately, because it doesn't boot, I don't think it's working correctly. And this is the main. I can't really get this. Okay, so this is the main processor, I believe, and these are some of the transceivers that I can see here. 8426D. So I believe those are the bus transceivers. And what is interesting here is you see this. I think this is just actually jumpers to jump these two sides together. I could be wrong, but it looks like this is just directly connected. And here we have the clock. This one looks a little corroded, but I'm not sure if that's the issue. We'll have to take a measurement there, but anyway, so this is a fairly common way to generate the clock using a 7404. This is a quad inverter, and we stick a crystal there to generate the square wave clock. So, and this clock is I believe fed into the rest of the system to make it so basically for the clock for the whole thing. So this one I think is the first digit is kind of covered, but I believe this should be a 10 megahertz clock. So again, you see some of the RAM here. Actually, that's quite interesting. So not RAM. I don't know what these are, but we do have our firmware. As you see, they are seated in this area. Now, I don't know if these things should be missing or they're just missing. Since I don't have any reference, you know, I wouldn't be able to figure out. That said, this looks like it's, let's see, what is the marking here? This is 2716. So these, I believe, are 16K UV erasable EEPROMs. And so most likely these are the ones holding the programming of the whole system. So if this board is dead, then really there isn't much that I can do to revive this machine because you know, number one, I forgot to mention earlier that this 859, you can't really find any you know, manuals on the internet, which is very strange. But that almost made me believe that this unit was probably not massively produced, because you can find very little information besides the basic characteristics, specifications of the unit. Other than that, you can't find anything. So I'm curious to see what are these, you know, whether or not these EEPROMs are bad. And anyway, so this is the MCU board, and the back, you know, there's nothing on the back. And we will take a look at the next card. Oh, okay. So this one has a looks like this has a 1, 2, 3. There's a 3.6 volt nickel cadmium battery. Unfortunately, I don't know if you can see here. The battery is kind of dead and leaking. So that probably contribute to the fact that it doesn't work. But most likely this is to maintain a real-time clock. And again, we have some, you know, like 339s here, and we have some 74 series logic here. And what is another interesting thing is that these are all switches. These are, you know, to set a certain configuration, I suppose, on the for the card. So very interesting. I don't know what it is, what they are setting, but most likely it's either for you know, for testing or for the post-production system configuration. Again, the back of the card is empty. So the next cards, these two, are identical. So I'm going to show one of them, but these are actually for you know, one of the channels. So I believe they are just the controller cards. Oh, look at this. This is very neat. So this actually is a 2-card construction, and one on top and one at the bottom. The one at the bottom, if you see, there really isn't anything in there. There isn't anything inside. So this seems to be the only component. So, and what is very interesting, I'm not sure if you can see this, are these traces. So these traces are basically snaked from here and back and forth, back and forth, back and forth, all the way to here. And so it almost seems like some sort of inductor pattern on this big card, which is very interesting. They use this big board area for these kind of traces. Wow. So that is, yep. So it says it's a delay and width PIGY. So it must be controlling the delay of the signal. So it's actually not a inductor. It's just a delay line. So let's see this side. So this side basically, really there isn't much to it except for all those 74 series logic. And so what this wave generator does is actually it can record some of the waveforms, and you can obviously adjust the repeat pattern and time interval. So there are a lot of counters and storage units involved to make that happen. So when all these are done in the 74 series, you end up with a lot of these kind of the boards basically. So as you can see, I find this like the silk screen here. It says a delay and width. So this board is probably for to generate the delay signal and control the width of your generated pulses. So we'll put this here, and the next one I think is exactly the same. So let's just take it out. Oh, this one is much tighter. Oh, okay, here we go. Yep, so this one is exactly the same. So you have this two board construction, and to increase it, to make it more rigid, they actually have this nice bar mounted at the back. So that's very interesting. So now we come to this card right here, and they have some coaxes. Those are the ones leading to the rear panel, and I first need to free these before I can take this out. Now this one is probably shared in common between the wow, these are really tight. Shared in common between these two channels, because there's only one such board in here. The camera makes a very awkward position. Hang on, let me turn out the camera, and after I remove it, I'll be back. Okay, it does take some effort to unplug those coax connectors, and so now we are free, and let's take this board out. So this is actually very light, this board, compared to the other ones. Again, as you can see here, we have these delay lines on all over the place. So it's interesting, like how they utilize the PCB. They use a significant portion of this PCB to etch into the PCB this delay lines, and so we see the input here to this coax. When it's clock, trigger in. I'm not sure what this. Oh, this is probably crystal out, I believe. And this is your. Oh, sorry, you can see this is a sink. So, besides that, again, this chip are this mainly are some of the logic, most of the logics here, and nothing much interesting. By the way, these things, this long strip you see in the previous two boards, these are probably just some resistors. I believe these are resistors that mounted, they share across all this board, all those chips. So let's see what is on the back. Oh, okay, nothing much is on the back, except there are two botched resistors here. So this is the I think that's pretty much for this board. Let's keep moving. Oh, so this board actually is pretty interesting. I believe this is probably where the RF signals, the signal, because this one does generate up to 15 megahertz signal. So this is probably what is in the can, which we can take a look later. And what do we have here? I'm not recognizing this chip here. This is a AD561J. So that is actually a 10-bit DAC. So there's some DAC going on here, and all this ceramic chips. These are really nice ceramic chips, and I think those are all the some of the logics. So this one, actually, I just looked it up. This one, the 100107D, is a that's a Quint exclusive OR chip. So there really is nothing to it. And then we have some resistor networks here, and so again, compared to the resistor networks here, you know, as one I just showed you, these are also resistor networks, but they do have some of the smaller ones here. And all these are resistor networks. So now let me take a look. Let's take a look at what's inside here. Okay, now I have removed the screws. Let's open it up. This is shielded, and has some sort of soft material. I suppose is to make sure it is tight. When you put this back on, it mates correctly. And inside, I was hoping to see some high frequency stuff, and I guess these are probably higher frequency, not extremely high, because just given how the layout is. And again, this ceramic chip here is nothing but a OR chip. I believe it's just some logic chip, probably faster than the normal ones. And there are some op amps, and I see this 356 again is an op amp, and there are some precision potentiometers. So really, again, there's nothing much to this board. So let's move on to the next one. So what we have here are these two identical ones. So actually, I'm gonna see what it. Oh, okay. So here's the coax connected. Let's again remove this. I'm not sure how easy or how hard it is. This one should not be that difficult. Okay, here we go. So let's take a look at the other one, because these are identical. So because I wanted to see what the heck is on that node, the left. Let's again remove this. Well, this board is probably where all the magic happens. Let's first read this note. So it said this card fails. Okay, fails the rise time test. And so the note was left on May 29th, 09. So this this unit probably has been fixed and tested, and some people are trying to fix it. Either this is done by the original original facility, or there's some other person before me, tried to fix it. I do not know. But anyway, so this actually is not our concern, because our unit doesn't really boot up. So it's more than just not meeting the timing requirement. So this is actually very, crowded, this board. Not only has this side, but it also has the other side as well. So let's take a look at this side. So this side is probably all these transistors mounted here, I believe, are for the output. So these are power transistors, and you can see these are mounted by a pretty hefty heatsink here. So what I see on the main side immediately, I saw something here. These two chips, I don't know if you can see the reading, read the marking here. These are 8565 JD. So these two ceramic chips are 12-bit. Sorry, these are 12-bit. I believe these are 12-bit fast DACs. So each of these probably gonna cost you about, like, I don't know, $50, something like that. So potentially we can still use these even if the unit doesn't work. But these are actually very fast DACs. Now, by today's standard, probably not fast, not that fast anymore, but still very decent DACs. And I believe you can still buy these today. Again, there are some 74 logics, and I see some op amps here, and potentiometer, and some of the something's heat sinked here. Let's see. Oh, sorry, something's heat sinked here. What is this? This is actually a 778 regulator. It's a 5-volt regulator. So now I'm actually amazed at how well this thing is made. If you look at the attention to details, some of these components here are, you know, soldered onto a tiny board, and the board is actually soldered back onto the to the bottom. So these probably are, you know, manually selected and tested, and then, you know, after they meet certain criteria, these are put down there. Or maybe not. Or this one, actually, now I'm thinking about this. This looks like this thing's been fixed. Wait a minute. Yeah. So if you look at the other one, the identical unit, the other one actually, these are just you know, soldered directly here. So this one must be you know, people trying to fix it at some point. Either that or in factory they're trying to fix it. So they went in the trouble of getting these kind of riser board and mounted one extra resistor here, presumably trying to meet the timing or whatever requirement they have. So that is very interesting. And without, you know, the schematics, these type of things are going to be extremely difficult to fix. So unfortunately, you know, nowadays you can, especially nowadays, you can kind of get this kind of a generator for next to nothing on eBay for a working unit. So these kind of you know, if it's broken and if it's easy to fix, we fix it. If it's has something to do with the microcontroller, then there really isn't any reason we should be fixing them, because they just, you know, just too cost prohibitive. So now let's move on to the I think we're near the end of this. This one here, that's the power supply board. So everything here is linear. So basically, what that means is, you know, instead of switching regulator, you all use a linear regulator. And the regulator here, so there really is nothing to this board. These are some like the bridge rectifiers, and here I see some 317s and 337s. And I also see some transistors, presumably power transistors, and more power transistors. So this big thing, this big thing is really just power supplying the power. And if you read carefully up here, I'm not sure if you can see these test points. So it has F1. F plus 35 1. So what that F means, I think it means it's floating. So later after I put it back, let's take a look at the power supplies. I probably should have done that first to make sure that this is not causing the problem. But since it boots up, I assume that the voltages are okay. But later, nevertheless, we'll check that later. Now, so this is you see here, this is a common, this is COM, and this is a -15. So this -15 is with respect to this COM, I assume. And this ISO 5 means it's, again, isolated 5 volts, I think. And this ISO-COM is the isolated common. Again, this is then we have here is a F plus 32/2, which means this, this node, the voltage is with respect to this floating ground here. So later we're gonna check all these voltages. Again, this is a F-15.1, H plus 15.1. So these are with respect to let's see where the F1 is. The F1 here. So those are the voltages with respect to that. And I forgot to mention that this unit, the reason they have floating supplies is because the channels are actually floating. So let's put this down instead of leaving it out there. So it's because the channel's floating, and that is, so you will need independent supplies that for each channel. So the grounds cannot be shared because of the nature of the outputs. So the channel's output ground is not tied to your chassis. So that's something we need to be aware about. And when measuring the voltages, you need to make sure that you understand where the ground actually is. So now let's take a look at what's left inside this unit. So there's one more board at the very end of this, on the side of the unit. This board is actually not plugged in, and I wanted to take it out to show you, but really there isn't much on that board. It's just some power transistors and stuff like that. And I think it either is a power distribution. Probably it is a power unit. It's just because from the wiring it connects directly. If you see here, let me just get my pointer here. So if you see here, the wiring comes out and goes all the way to your transformer. So given that, I don't think there's much on that circuit. So I'm not going to take it off, because also this has some rivets, linked to the back of the side. So I have to probably take the side off before I can show you that. So towards the end, there's really nothing much, and that's just your power supply. Sorry, that's just your transformer, and some very big capacitors. And I do want to take the other side of the front panel off, so to show you some more there. So just give me a few minutes, I will take those off. Okay, so now I removed the screws holding the front panel back. Let's take a look. Okay, so as you can see, let's move this camera down a little bit. And there really isn't too much on this front panel either. So there are just some, so this big chip is driving the displays, and the displays are those 7-segment displays, and then I believe there's a keyboard controller somewhere. Maybe this is a keyboard controller, because this thing connects to here, which connects to your front keyboard. Now the keyboard of this unit is very interesting. This one and some other WaveTech models use this kind of I think it's similar to capacitive sensing, because you can't really push these buttons down, and you just touch the button and it's supposed to register your presses. Now that is it doesn't give you a lot of feedback, unfortunately, but I suppose that's some of the trend back then, but nowadays, ironically, it comes back, the capacitive sensing, but it's of course at a much different scale, and the usability of nowadays capacitive sensing is dramatically improved over the past. So I don't see anything else on this board except for the logic and to drive these the display. And what I do see is the power button here. That's a power button mounted towards the front, and this one actually wired all the way through the heatsink, wired all the way towards the back of the unit. So you wire all the way to the back to switch the actual main transformer. So that's pretty much what I can show you in this unit. And before I put the unit, before I close up the unit, I wanted to put all the boards back in just to verify the some of the basics, to see if the unit is worth trying to repair or not. Before I put back the processor board, I just want to take a quick look to see if actually the oscillator is working, because I'm not sure if you can see from this angle, but that oscillator is a little bit of like corroded at the bottom. And I mean, if the oscillator is not working, there's no way the processor board is gonna work. So I kind of want to just eliminate some obvious before I before I declare it dead. Now this oscillator board is powered by plus 5 volts, and just a standard TTL logic. And I traced the pins, and it's apparent that the two terminals on the card edge, on either edge, is actually the plus and the ground. So here I have a my meter here. Let's just see. I just applied the 5 volts. So this is exactly almost exactly 5 volts. And there's some of some voltage drop across the wires, because this thing does draw quite a bit of current rather. This thing draws about 800 milliamps when idle. Anyway, so now I hook up my scope, and as I will show you here, is so the test point 2 here is also ground. So if I probe the oscillator, I do get the signal. So the signal, it says, is actually 10 megahertz. So that appears to be working. And if I just, try to poke the output of my, yeah. So it looks like that our oscillator is working properly. So, and that's not a jitter, it's just the weird position of my probing here. It doesn't want to stay. So yep, the output also, it's a 10 megahertz spot on. So it seems that our clock is alright. And if I just poke some random places, I do see some of the pulses, like passing to passing. This is not long enough, so let me just put it here. If I just randomly check some of the, I don't have the data sheet of this the processor, but if I just lower my time base, and if I see some of the signals going through, so are some signals. So which means most likely the processor is working. There's just some jumping around because of the triggering pulse or something like that. So actually, to see that even more clearly, we'll lower the time base once more. So there's a pulse. Yeah. So there's some data or some enabling pulse. So it looks all right. So unfortunately, I'm tempted to think that one of these ROMs either are bad or or corrupted or something like that. So unfortunately, without any of the these kind of EEPROMs, I can't really do anything more about this unit. So it's unfortunate, but a lot of these old instruments, they actually have a lot of nice parts on them. You can definitely reuse. Not so much of these 774 series, but the DAC I mentioned earlier, and also those precision potentiometers, and are definitely something that you want to keep. And of course, this unit is draws a lot of power. As I mentioned earlier, it draws about 300 watts. So it has a very beefy power transformer, so you can use that for other projects as well. So so before I formally declare it dead, I'm gonna measure the power supply output voltage, just to make sure that it's not the power supply that is causing the problem. So let me reassemble everything together, and we will measure the power. Okay, now I put it back together, and I just want to test one more thing. As I mentioned earlier, I wanted to see that if the power supply output voltages are correct. But let me try to power it down. I haven't done it after I put it back on yet. No, it's exactly the same thing as you saw before. So now let's take a look at the voltage. I hope you can see the multimeter here, and the fan is very noisy. Let's try to see it here. So the first thing I want to see is channel 1. Let's find the channel 1 common. F1 is channel 1, I believe. So here I should have a minus 15 volts. Yep, we have spot on minus 15. And this one we should have positive 15. Yep, positive 15 spot on. And let's see, this one we should have a, I can't see this. Let me just see here. It's 35. Okay, so we have 35 spot on. And the channel 2, let's see the channel 2 here. Where's my channel 2 reference? Channel 1, that's, I think this is channel 2, yeah, channel 2. So let's see channel 2, this one should be minus 15. Minus 15 is alright, and plus 15, yeah, the voltage is correct. And this is a plus 35, I think. Yep, so the voltage here is correct. And now the isolated 5 volts, it's almost spot on. So I don't think there's anything wrong with the so there's a 15, I think. Is that isolated or not? Wait a second. Yeah, that's 15. So that's a little bit high, but you know, it's it shouldn't really matter. 15.6. So all the voltages look fine. So unfortunately, I think this there's really something going on with that processor board we looked at earlier. So even though you know, all the oscillators, everything seems to be working, and apparently there's something wrong with the with this unit. And as also you can see that there are many of the cards the previous person marked it with Axis, which means those are presumably bad. So unfortunately we can't do a whole lot more here, but nevertheless it's very interesting to see a construction like this back in the 80s, and especially nowadays you know, you don't see this very often anymore. So I hope you enjoyed the video, and let me know if you have any ideas and comments, and please let me know. And if you know how to resolve this issue, and you know, also please shoot me a note. Thanks. See you guys next time.